I see what you mean. I was thinking that you had a question on these lines that I put. But if it's undefined, I can never use a bracket. Is this okay?
So we don't have to write it out if we show you on the table.
Yes.
Okay.
If you don't use a table, summarize the information somehow, and then you can have to write it. It's up to you. If you don't write it, but you show this, then I know you know what the domain is. Okay, now, only now, I can simplify. And the simplified form of this expression, this rational function, is 1 over x plus 3. The factor that went away, if you go back to your notes, and I should have gone back to the notes from, oh, I did, but I didn't point out where I wrote the exception. So because x equals 3 disappears, or x minus 3 as a factor disappears, this is still undefined, but it will be a whole. This factor still stays. X equals negative 3 will be a vertical asymptote, which means left and right we will have infinities. No question. I don't know the signs. But now, in order to determine what happens left and right of the whole, I have to plug in 3 in the simplified form. When I plug in 3 in the simplified form, what do I get left and right? Please evaluate for 3. 1/6, very good. That's it. We will determine now the signs of the infinity with negative 3.1 and negative 2.9. Please evaluate the function. I only need the sign. Evaluate the function with negative 3.1. The simplified form. Do we all agree with negative? Excellent. Please evaluate the function with negative 2.9. I only need the sign.
Plus.
Perfect. I would like to get the y-intercept. Please evaluate for 0 so we can find the y-intercept. No. 1 over 3. Very good. Awesome. So now, give me the end behavior. Look at this and tell me which type of function is it. If it's type 1 or type 2. So what is the horizontal asymptote as well as the end behavior? 0. So y equals 0, horizontal asymptote. And you are done. Let's graph it. Of course, it's not symmetric. You cannot have a hole on one side and a vertical asymptote on the other. So I'm going to say f of negative x does not equal f of x, does not equal negative f of x, which translates into not symmetric.
The problem with the whole probably wouldn't be on the test.
So why do you think that why is the setup difficult? Or we only simplified, so we simplified, and we realized that this factor goes away, so it cannot be a vertical asymptote. This factor doesn't go away, so it's a vertical asymptote. You need it for homework anyway. I don't particularly have a preference for this, but I just want you to see it. Sure. So now let's graph. When we graph functions with asymptotes, what do we have to graph first? Excellent. Thank you. We have to graph the asymptotes. How many asymptotes does this function have? 2. This will be an overkill. Sy equals 0. There is no need, but it's there. Okay, then x equals negative 3 is this. Vertical asymptote x equals negative 3. Let's plot the whole so we don't forget. Difficult for me to plot 1/6. So I'm just going to say here. At 3, left and right, 1/6. It's this point. So now let's see, from 0 to negative infinity, from 0 to negative infinity. In the middle, I mean on the right hand side of the next asymptote is positive of the vertical asymptote. 0, 1/3 is this point. I'll make it a little bit higher. And this is what it is. So then f of x equals x minus 3 over x squared minus 9. Let's graph this with a graphing calculator. So you see the graphing calculator doesn't know as much as you do. So in y equals, clear if you have anything in there. So the top x minus 3. Don't forget to put parentheses. And then x squared minus 9. Don't forget to put parentheses around the denominator as well. So x minus 3 divided by, in parentheses, x squared minus 9. So if you use zoom in 6, because I used it for something else, so I have to adjust the viewing window, here's what we get. And the vertical asymptote is negative 3. So from 0, it approaches negative infinity. Negative infinity on the left-hand side of x equals negative 3. On the right-hand side is coming from positive infinity, and everything looks perfect. Do you see that there is no vertical asymptote at x equals 3? Definitely, right? Okay, but now let's zoom in. I am going to zoom in right here in this area. So I go to Window. I only want to see between 2 and 4. With a scale of 1 is fine. Y minimum, I wanted negative 1 to y maximum 2. And I want to graph. So I'm only zooming in that area. And now I see it. Right? There's a little gap in there. But it's not a vertical asymptote, because a vertical asymptote means the left and right, the function has to go to infinity or negative infinity. And it's not doing that. The function just has a little hole in it at x equals 3. Why? Because the factor disappears. Otherwise, it would have had a vertical asymptote at that point. Yes?
So what would be like a real life application of this? Like, you have these holes. Is there anything like
It's
that?
just, it only says that the function is undefined at that point. It's a very good question. I don't see, I can't think of a particular application in real life of this, other than when we determine a function that works for most of the points, but it doesn't work for some of them. So the function may have a blip in the graph, yeah. Good, but it was a very good question. I wanted to show that to you. So it's I'm just checking my memory. When you get to my age, you will do that a lot. Here it is. A rational function has a vertical asymptote where it is undefined, except when the factor goes away. Like here, x minus 2 went away, x equals 2 is not a VA. Good, so I guess enough of that, so let's continue. So let's look at this handout, and you choose what is next. We may not be able to finish everything, so let's pick and choose. Number? Number 3. Okay. Okay, that's fine. Number 3 is good. So in number 3 we have f of x, negative x to the 4th plus 25x squared. In this problem we are asked to graph. So remember, you have all the list in there. Again, if you're using the table, you don't have to write much. I really don't want this problem to take more than 3 minutes of your time. It's a nice problem, it's an important problem, but I don't want you to spend too much time on it, right? So what is the domain of this function? Because it's a polynomial function. Perfect. Okay, so let's write degree. 4. How many x-intercepts or zeros will I have to find? Or solutions? Yes, 4 solutions. Perfect. Max possible number of turns. Exactly, the degree minus 1. Awesome. Great job. And behavior. Degree is 4, and the leading coefficient is? Good. So there are only 2 possibilities for even degree. One possibility or the second possibility. Which one is it? Of course, because the leading coefficient is negative. Excellent. So here is in 3 to 20 seconds, here's what we determined. Maximum possible number of turns, degree, and behavior. It took us less than 20 seconds to determine these 3. And of course, domain. Okay.
What's the end behavior again? It's negative 2.
Negative infinity to negative infinity. Yes.
How do you get the term for 3 for the maximum term?
Is the degree minus 1.
Oh, okay.
The degree is 4. Degree minus 1 is the maximum possible number of turns. It doesn't have to turn 3 times, but it cannot turn more than 3. Very good. Now let's determine the x-intercepts and multiplicities. What do I have to write for the x-intercepts? Good. So negative x to the 4th plus 25x squared equals 0. I refuse to solve an equation with a negative leading coefficient, and so should you. So I recommend multiplying both sides by negative 1. X to the 4th minus 25x squared equals 0. What now? I have to factor out. Excellent. What? Perfect. So I have x squared and x squared minus 25 equals 0. And I have to continue factoring because x squared minus 25 can be further factored. Very good. That's the reason why from the very beginning we established this, so I don't forget. So then I have to see 4 solutions. Exactly. Excellent. X equals 0 multiplicity 2. X equals 5 and x equals negative 5 multiplicity for both of them. 1. 2 plus 1 plus 1 has to give us the degree.
Why is 0 2 multiplicities again? Because it's the x squared.
Because it's x times x. Yes, that's the answer. Because it's x. Yes, Rachel?
Never mind. I just went back.
Okay. So what does multiplicity 2 mean? I have to go back and write negative 5, 0, and 5, and 0, 0, 0. That's how I determine them. Y is 0 when x is negative 5, 0, or 5. Turn, cross, and cross. Multiplicity 1 is a straight cross. Multiplicity 2 is a turn. Is that okay? So let's see, let's go back to the, so we determine the x-intercepts and multiplicities and their meaning. The y-intercept, I already have it, I have to make x equals 0. 0, comma 0, that's the y-intercept. I can write it. Y-intercept is f of 0, but that is 0. So that is done too. What is left? Nothing. Just the max-min with the graphing calculator and the symmetry. But I'm done. So is this symmetric? What do I have to find in order to show symmetry? Excellent. F of negative x. Nothing changes in this function. Will equal f of x. Because if I replace x by negative x and I raise it to the 4th power, no change. If I replace x by negative x and I raise it to the 2nd power, no change. So what type of function will do this? F of negative x equals f of x. Even. Yes, with respect to the y-axis. Remember, even is like this, and odd is like this. But this is not the case because the end behavior is not negative infinity to positive infinity or the other way. Let's graph. Does this function have asymptotes? I'm asking because I always see asymptotes now almost in every test. Students forget that polynomials are continuous functions, no restrictions, no gaps, no jumps, no holes, no vertical asymptotes, no horizontal asymptotes, nothing. This is a nice function. And I see a vertical asymptote and then something that crosses. So please, no asymptotes, polynomial function. Okay, so I'm going to plot negative 5, 0, 0, 0, and 5, 0. That's the first step. Ready? So the function is coming from negative, bless you, it's coming from negative infinity and crossing at negative 5, 0. It's coming from negative infinity and crossing at negative 5, 0. I see in my notes that it has to come to the origin where it's turning. It must turn so that it comes back and turns again. I don't need anything else to look at anything else. Why? I know the function is even. I only have to copy on the other side. Nothing else. So this is f of x, negative x to the fourth plus 25x squared. I'm done with the graph. However, I need to determine the max. So let's put it in the graphing calculator. I know the min. This is the minimum local. Min is at 0, 0. But these two must have the same height. How do I know that they have to have the same height? Because the function, exactly, because the function is even. So they will have the same y value, but they will not have the same x value. We know that. So now, only now, we should put the function in the graphing calculator and find the maximum. So let's do just that. Here it is. In y equals, clear everything you have. And this is negative x to the fourth plus 25x squared. Sorry, negative x to the fourth power. I always do that. I forget that this software. Okay, plus 25x squared. Okay, so then let's go to zoom 6, because remember I changed the viewing window. And it's coming from negative infinity, crossing at negative 5, will turn somewhere. It turns again at 0, 0, which is the local minimum, goes back, it's completely symmetric, and it crosses at 5, 0. However, this is way up there. Let's change the viewing window with window. Let's say negative 7, that's good enough, to positive 7. Scale of 1 is fine. Y minimum, I don't know, maybe negative 5. And Y maximum, it shows like it's way up there. I'm going to say 300 with a scale of 50. Let's see what happens. And click on graph. It's coming from negative infinity, crossing at negative 5, 0, as expected, comes back and turns at 0, 0, and again. So let's determine this, and then we already automatically will have the other one. So finding this maximum, second in calc, it's a maximum which is number 4. Left bound is negative 5. Right bound is 0. And I don't want to guess, just give me the number. So the maximum is negative 3.5. And the maximum value is 156.25. Can anyone, without calculations, give us the other peak? 3.5, comma, 156.25, of course.
Wait, I'm sorry. Can you go over that again?
Yes.
That maximum with the calculator, I didn't do it.
To do what?
To get your maximum, like what you
So second in calc. And the left bound is negative 5. and the right bound is 0. So you choose maximum. And then the left bound is 0. The left bound is -5, forgive me. Press enter. And the right bound is 0. And then you don't want to guess. Unless you want to put in a number, it's fine.
How did you do x to the 4th? You only have x to the 2nd.
Caret 4. So caret 4.
Okay.
It's like a hat. This is called caret.
Oh.
Yeah, like a hat.
Okay.
Yeah,
So you just put it in. Okay.
yeah, that thing and then 4. Are we okay? Did we get it?
I touched the button.
That's okay. Did we get it? Everyone?
Okay, so it's still a good question, but why? So left bound is -5, right bound is 0, but why?
Because I know it's between -5 and 0.
Could you use the other one if you wanted to? Didn't matter if you want to use 0.
No, because it's symmetric, but otherwise
Yeah.
it's got, yes. Yeah, you can use 0 and 5.
You're
Absolutely.
gonna get the same one.
Of course. Yes. Very good. So we talked about it and so on and so forth, but I don't want you to spend too much time on this problem. Good. Next question, please. What would you like to look at next?
Number 6.
Number 6. Let's take a look at number 6. So for number 6, we have two functions. We have f of x, which is the square root of x minus 1 over x minus 3. And we also have g of x, which is 27 over